Oh man, I'm going to take the elevator next time. Hit the intro. Do still math, still math. Do still math. Hey guys, how are you? Out of breath from taking those stairs. Woo woo woo. Okay. Today, what we're going to talk about is square roots. We are going to go into what a square root is, how to find a square root, how to simplify a square root. Okay. So let's start off very basic. What is a square root of a number? The square root of a number is not dividing what's under the radical by 2, okay? The square root of 10 is not 5. The square root of 20 is not 10. The square root of 100 is not 50. The square root of 4 is not 2. All right, forget about the square root of 4, but it is not dividing by 2 each time. The reason why the square root of 4 works is because 2 times 2 is 4, but 2 plus 2 is also 4. So there's your problem there. So what is a square root then? It is what number times itself equals what's under the square root symbol, the radical. Okay, so let's do a couple examples. So I wrote a few here. So I want to show you what they are. I mean, you probably know this one off the top of your head. Maybe this one, maybe that one. I'm going to show you why they work as well. So the square root of 9. What times itself is 9? The answer is not 4.5. I'm going to be saying that a lot because as I've taught this for a few years, every time somebody tries to divide by 2, do not divide by 2. So the square root of 9 is what number times itself equals 9? The square root of 9 is 3. Why? Because 3 times 3 is 9. The square root of 16. What times itself is 16? Still didn't hear you. 4, though. 4 will be the answer there. Okay? Did I make that backwards? No. In the camera, it's backwards. So this is quite fun trying to figure this out. The square root of 100, somebody may be yelling, it's 10. 10 times 10 is 100. If you're yelling that, awesome. If you're not, it's okay. I'm going to explain why. It is 10. But let's talk about why. Okay? So I'm going to teach you a little trick. All right? And that trick is, let's use the square root of, let's start with something very basic. So let's start with square root of 9. If we had 9 up here and we wanted to create a factor tree, you should remember doing factor trees from earlier, but what they are is you're splitting up what times what equals 9, and you can keep going farther and farther until you get to prime numbers. So don't use 1 as well because 1's not prime, okay? But the only thing that works for 9 is 3 and 3. So you're actually going to stop there. But once you get to the bottom and they're all primes, you circle your pairs. I've got a pair of 3s. Where those pairs go is then outside the radical. So if I'm simplifying the square root of 9, if I had square root of 9, anything that's not circled is going to stay inside, but there's nothing left uncircled. So there's not going to be an inside when we simplify it. So that's why it is just 3. The 3's go outside. All right, and hint, hint, all of these are going to be that way, but we're going to show some examples where it's not a perfect square. What's a perfect square? Oh, I heard you. No, that was actually, I heard the voice in my head. A perfect square is just like these, where there is a number that actually works. 3 times 3 equals 9. What if I went one number bigger? What's the square root of 10? Yeah, me either. I couldn't tell you without using my phone and figuring it out or a calculator. All right, these are perfect squares. So think about it. 1 squared is 1. So the square root of 1 is a perfect square. 2 squared is 4. Square root of 4 is a perfect square. 9, 16, 25, 36, and so on. Okay, 6 squared, 7 squared, 49, 8 squared, 64, 9 squared, 81, 10 squared, 100. Those are your perfect square roots, perfect squares. So if you see, what's the square root of 64? That should be a quick 8, because I know 8 squared is 64. So let's do another example. Like, let's do 16, because it's going to be a little bit different. What times what is 16? And you may be saying 4 times 4, but doesn't 8 times 2 also work? So let's go that route. Let's say 8 and 2. 2 is prime. I'm going to underline it because we got the prime. 8 is 4 times 2. Another prime, 2. But 4 can still be split up as 2 times 2. Prime, prime. So now we've got all primes. And remember, we're circling our pairs. The pair of numbers, okay? So there's a pair of 2s. There's a pair of 2s. So I didn't clear this up here, but I'll show it down here. What that does not mean is that you now have 2 times 2 times 2 times 2. No, it takes a whole pair to get outside of a radical, because remember, it's things squared. So a pair of 2s inside of a radical equals 1, 2 outside. So if we have the square root of 16, there's nothing left underlined. This may make more sense when they actually don't work perfectly, and I'll show you in a second. There's nothing left underlined, so the square root of 16 is 2, there's one pair, times, you always combine them with multiplication, 2, the other pair. And 2 times 2 is 4. So that is why the square root of 16 is 4, besides the fact it's just 4 times 4. All right, let's try and do one that you do not know the answer so quickly to. Let me turn here a little bit. So the square root of 20. If we take 20 and split that up, what times what is 20? Okay? 2 times 10. Simple. 2 times 10. That's prime. I can't split it up anymore. Yes, I could say 1 times 2, but 1 doesn't help us with anything because 1 times a number is that number. So it doesn't help. I could do divide ones all day. I could add whiteboards like around the wall. I could do whatever with ones. That would go forever. 10 is 2 times 5. Those are both prime. So we're going to stop here. I told you before, we circle our pairs. Leave our singles underlined. This is the first time we've had something that did not get paired up. So what do we do with that? When things do not get paired up, they stay inside the radical. So the square root of 20 is what's outside the radical? The pairs. So there's a 2. 2 goes outside. And then we've got to bring the radical back. And what goes inside? What's left underlined? So your answer is 2 square roots of 5. That is the simplified form of the square root of 20. 2 square roots of 5. Okay? It's very important we learn how to simplify square roots, because if we can't simplify them, we can't add them together, we can't subtract them. We have to know how to get those simplified. Also, you've learned since early, when you have a fraction that needs to be simplified, you simplify it. Right? When you have 2 times 3 as your answer, you simplify it as 6. This is the same thing. You don't want to leave a radical unsimplified. Simplify it. Okay. Let's go to the next problem. One more. Square root of 76. What in the world is the square root of 76? Honestly, I picked this number because I can't think of what goes into it quick either. I know it's even, so it may simplify, or it may stay square root of 76. Let's see. So we've got 76. I know it's even. So I know 2 times 38 works. Still even. So I can tell that I'm going to be able to factor out a 2 because that's going to be 2 times 19. 19 is prime and my 2's are prime. Circle my pairs. Leave my single underlined. And now when I simplify, the square root of 76 is equal to 2, because that pair comes outside, times the square root of 19, because that stayed underlined. So the square root of 76 simplifies to 2 square roots of 19. Okay? Please feel free to go back and watch this video again. If you need more help, let us know. The biggest thing to tell you is square root does not mean divide by 2. I don't want to look at your worksheets and see that you say the square root of 40 is 20. It is not. Okay? So, I think that's it for us today. You guys have a wonderful day. Watch out for puddles. And I am not taking the stairs back. I can promise you that. All right. Let's see. Boop, 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 boop. Bye.